So let's see actually how it works. Okay, I'll give you a brief. Switch 1, switch 2, switch 1, switch 2. Those are connected, right? My port number 1, my port number 2, my port number 5, my port number 6. Okay, so by default, spanning tree protocol is enabled on all the switches. It is enabled on all the switches. So what will happen is this switch and this switch, both switches, okay, they will spanning tree protocol uses BPDUs, that is bridge protocol data unit. Actually these are the messages used by spanning tree protocol. Okay, so whenever the STP is enabled on the switches, every switch by default, every switch will think that they are root bridges. They are, it will think that it is a root bridge, and the switch 2 will think it is a root bridge. Right? Very simple. Root bridge is like leader. 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 Okay. So now switch 1 thought he is the leader and switch 2 thought he is the leader. Right? In spanning tree, only root bridge will generate the BPDUs. You got the rule? Yeah. Right? Please make a note of all these things. It's important, or else you take the video and you need to revise at home. Okay? From the starting point to till today. If not, it will be hard. Okay? So only root bridge will generate the BPDUs. Okay? So now what happened? He thought he is the root bridge and he thought he is a root bridge. He will generate his root bridge and he will forward it to switch 2 through both the interfaces, through this interface, through this interface. Okay, switch 2 will also forward the BPDU on both the ports, on this port and this port. Right now he will compare, switch 1 will compare his BPDU, that is whatever the BPDU he has, he will compare his BPDU with switch 2's BPDU, and same here, he will compare his BPDU with the switch 2's BPDU, switch 1's BPDU. Okay, for time being, okay, actually switch 1 and switch 2, every switch will have one base MAC address, one base MAC address, one base MAC address. Okay, and every switch will have one bridge ID. What will they have? Bridge ID. In the sense, it is like very simple. Usman is your name, right? Similarly, in span and tree, every switch will have one identification. We call it as bridge ID. Okay. So what is bridge ID is actually It is the combination of priority plus base MAC address. What is bridge ID? Base MAC address. Okay. So now in BPDU, this bridge ID is sent. Okay. In BPDU, sent. He will send his bridge ID. He will send his bridge ID. Right? In the BPDU. Now what will these switches do is, first they'll compare their bridge IDs. Ultimately, there must be only one leader, right? Yes. If there are around 2 to 3 leaders, okay, if there are around 2 to 3 leaders, the people who are following them, they'll not come to know to whom they should listen. Yeah. If there is only one leader, then the administration will be perfect. The same thing here. So ultimately, there must be only one root bridge. Then who should be the root bridge? It will be decided by the bridge ID. Okay. Now he compared his bridge ID with the switch 2's bridge ID, and switch 2 compares his bridge ID with the switch 1's bridge ID. Okay. Low. In switching or in switching part, we'll be having low. Okay. Lower one will win the race. Okay. So for time being, think that his base MAC address is A and his base MAC address is B. Okay. And in spanning tree, by default the priority will be 32768, and here also the base MAC priority will be 32768. Okay. So now he sent his bridge ID 32768 plus A. He also sent his MAC bridge ID 32768 plus B. Okay. Now they are comparing it, right? In comparing, what will they see first is, first they will check priority. What will they check? Priority. And if the priority matches in the bridge ID, first they will check priority, and if the priority matches, then they will go for the base MAC address. Right? Now both they are having the same priority, then they will go for base MAC address. Base MAC address. Okay. So switch 1 is having base MAC address A and switch B is having base MAC address B. Right? Switch 1 is having base MAC address A. Switch B is having base MAC address B. So A is lower to B. Okay. A is lower to B. So switch 1 will be the have you ever heard of hexadecimals? Hexadecimal, right? In hexadecimal, 0 is 0, 1 is 1, till 9 is 9, but 10 is
11 the
same thing here. MAC address is represented in hexadecimal, right? So in that point of view, I wrote. So A means 10 and B means 11. 10 will be lower to 11. So A is less than B. So what happened? A becomes a root bridge because he compared his priority first, then he went for base MAC address, and switch 1's base MAC address is A and switch B's base MAC address is B. A is lower to B, so switch 1 will declare that I am the root bridge. And even switch 2 does the same thing, same process, and it will come to know that yes, switch 1 is the root bridge and I will be the non-root bridge. Switch 2 will be non-root bridge. Okay, so now what will happen? Switch 1 will generate BPDUs. Switch 1 will generate BPDUs. Switch 2 will receive them. Switch 2 will receive them. If it is having any switches beyond it, it will forward the same BPDU to that switches. Got it? Now the responsibility of non-root bridge is receive the BPDUs and forward the same BPDUs to switches beyond him or behind him. Right? Switch 1 is a root bridge.
Yes.
He will generate the BPDUs and he will forward it to the whatever the switch is connected to it. Okay, so this is the root bridge election. Okay, so what actually we are doing is switch 1 and switch 2. Okay, switch 1 and switch 2.
Yes,
Actually, the what process we are doing is why we are doing is actually here we are having two links.
yes,
That is why loop has occurred, right?
yes.
So now spanning tree, what it does is it will make work only one link. Okay, for suppose think this is link 1 and this link 2. What it will do is it will make work only link 1. Though the link 2 is available, what will it do is it will keep this link 2 as buffer. It will keep it aside, right? Only switch link 1 will be working, right? Once if the link 1 has gone down, then spanning tree will make link 2 make work. This is the actual working of spanning tree protocol. Okay, in order to do that, in order to in order to make link 1 work and make link 2 buffer, it needs some process, right?
Yeah.
In order to do that process, first it will elect one leader. Okay, first it will elect, yeah, the process we have seen, that is for electing the root bridge.
Yeah.
Okay, spanning tree will elect first one root bridge, that is leader. Okay, after that it will elect root port. After that it will elect designation port. It will elect designation port. Whatever the ports are there, whatever the ports are there on the switch, they must be either the root port or they must be designation port. If any port is not getting any either of these roles, then it will go for blocking state or else blocking state or blocking port. Blocking port. Okay, so for time being, think that here it has become designated port. It has become designated port, right? On switch 2, this port has become root port. This will be the block port. Now my topology will be switch 1 is connected to switch 2, right? This will be the my logical topology. My physical topology is this. Physically it is connected with two links, but logically only one, because this port has become blocking port. When it becomes blocking port, it will never forward the data. Okay, this is overall process actually happening in the spanning tree. So in order to do this, what the process, in order to do this, what happens is we are discussing now. So you know how leader will be elected,
Yes.
right?
No, no, not
Yes.